Hey, algebra students, in this lesson, we're going to be talking about solving multi-step absolute value inequalities. That in order to solve these, we first need to do some other work to get the absolute value expression on a side by itself. That's our goal. We need to get the absolute value expression on a side by itself. Now, to just take a look at some of these problems. In letters A, B, and C, notice the absolute value expression is just the x. So we're getting the absolute value of x on a side by itself. In D, E, and F, notice that the absolute value expression inside the absolute value signs is actually a whole expression, x minus 9, 5x minus 5. We have to get that whole expression on a side by itself, evaluate the absolute value, and then solve from there. So that's what we're going to be doing in this lesson. Then we're going to do one word problem. Let's get started. So starting with letter A, we need to solve 5 times the absolute value of x plus 6 is less than 31. First thing I'm going to do with this one is, as I write this out here, 5 absolute value of x plus 6 is less than 31. I need to subtract 6 from both sides to work on getting the absolute value of x on a side by itself. Okay, there we go. When I subtract 6 from both sides, I get rid of my 6 on the left. On the right, 31 minus 6 is 25. Okay, I should probably put a letter A in front of this so we know which problem we're working. Next, I'm going to go ahead and divide both sides by 5. Okay, when I divide both sides by 5, I'm going to end up with, let's see, it's just going to be the absolute value of x on the left is less than 25 on the right. 25 divided by 5, so it's less than 5 on the right. Okay, and now the rest of this is really easy to solve. I'm just going to go back to my absolute value inequalities method. And I remember that whenever I have a less than sign, that actually means and. Okay, so remember when we evaluated absolute value equalities with an equal sign, it was x equals 5 or x equals negative 5. Because we have a less than symbol, what we need to do is say x is less than 5. Less than is the and, so I need to write and x is greater than negative 5. X is less than 5 and x is greater than negative 5. And then the other way to write this, I'm just going to write this in the way that combines them. Negative 5 is less than x, which is less than 5. All right, let's make sure we did this one correctly. So letter A, there we go. Negative 5 is less than x is less than 5. Notice that when I graph it, I have an open circle at negative 5 and at 5, and I shade in between. That is the absolute value inequality. Let's move on to letter B. In letter B, same sort of thing, except I have a division going on. So it's going to be the absolute value of x over 7 minus 3 is greater than or equal to, I'm just going to write that like that, 1. First thing I'm going to do is add 3 to both sides. That's going to get rid of 3 on the left, and that's going to make the right side 4. Now I'm going to multiply both sides by 7. Multiplying both sides by 7 gets rid of the divided by 7 on the left, changes the right side to 28. I don't flip the sign because I just multiplied by a positive, not a negative. All right, now this is a greater than. An absolute value is greater than. I need to get rid of the absolute value symbol. Greater than has an R in it, and that reminds me that it's an OR statement. So I've got x is greater than or equal to 28, or x is less than or equal to negative 28. Okay, notice the pattern. X is greater than or equal to 28. I just rewrote this without the absolute value symbol. And then I flip the sign for the second part. X is less than or equal to, and then I make it negative 28. All right, this one I can't write as a single inequality. I can't write a disjunction as a single inequality, but let's see if I did this one right. There it is. And then when I graph this, I'm going to have closed circles at negative 28 and positive 28. I'm going to shade away from each other. Let's go on to letter C. In letter C, we have negative 4 times the absolute value of x plus 9 is greater than negative 1. First thing I'm going to do is subtract 9 from both sides. I'm going to subtract 9 here. That makes this negative 1 minus 9 is negative 10. Then I'm going to divide both sides by negative 4. Wait a second, what did I just say? I'm going to divide by negative 4 on both sides. That means that because I divided by a negative, for my next step, I have to switch the inequality sign to the other side. This is going to be the absolute value of x is less than, because I divided by negative 4, negative 10 over negative 4 is just going to be 10 over 4. I can simplify this fraction and make this 5 over 2, 5 halves, also known as 2.5. Okay, now I need to get rid of my absolute value sign. This is an less than, which is an and. So it's going to be x is less than 5 halves, and x is greater than negative 5 halves. The other way to write this is negative 5 halves is less than x, which is less than positive 5 halves. Let's make sure that we did letter C right. There it is. Notice that they use 2.5 or negative 2.5. That's the same thing as negative 5 halves and 5 halves, so I'm okay with that. Moving on to letter D. Different. Now I'm going to get the whole absolute value inequality. I'm sorry, the whole absolute value expression on a side by itself is going to be more than just the absolute value of x. In this case, it's the absolute value of x minus 9. Everything in the absolute value symbol needs to be on a side by itself. Okay, so watch how this works. X minus 9 plus 3 less than or equal to 10. First, I'm going to subtract 3 from both sides. When I subtract 3 from both sides, I get x minus 9 is less than or equal to 7. I can't go any further from here without evaluating the absolute value. I can't pull anything out of the absolute value sign until the absolute value sign is gone. So I'm going to note that this is less than, which is an and statement. And this is going to be no more absolute value symbol. X minus 9 is less than or equal to 7. Just rewrite what I had above. And x minus 9 is greater than or equal to negative 7. Now I'm going to solve each of these expressions. This one I need to add 9 to both sides to get x is less than or equal to 16. And then I still have my and. On this side, it's going to be plus 9 on both sides. X is greater than or equal to, and let's see, negative 7 plus 9 is 2. 2 is less than or equal to x, which is less than or equal to 16. Let's just double check to make sure that I did that one right. 2 less than or equal to x, less than or equal to 16. Notice the closed circles at 2 and 16, and then we shade in between. All right, on to letter E. Letter E, I have the absolute value expression, x over 2 plus 5. I have a lot going on inside the absolute value sign, but I can't touch anything inside the absolute value sign until I get rid of it. And the only way to get rid of it is to get on a side by itself. So the first thing I'm going to do is I'm going to add 9 to both sides of this equation. That's going to get rid of the 9 on the left. It's going to make the right 7. Okay, now I need to evaluate my absolute value, and from there I'm going to need to solve each side separately. So it's going to be x over 2 plus 5 is less than 7. Less than is the and, so I'm going to write and it's going to be x over 2 plus 5 is greater than negative 7. Okay, excellent. Now I am going to solve this left-hand side equation. I'm going to start by subtracting 5 from both sides. X over 2 is less than 2. And then divide both sides. Multiply both sides by 2. X is less than 4. I'm going to put an and in between. Okay. And then over here, I need to do the same thing, except I just need to evaluate on this side. I need to subtract 5 from both sides. It's going to be x over 2 is greater than negative 12 when I subtract 5 from both sides. X when I multiply by 2 is greater than negative 24. So my final expression is going to be negative 24 is less than x, which is less than 4. Let's make sure I got letter E right. Letter E, negative 24 is less than x is less than 4. Notice the open circles, and I shade in between. All right, letter F. We're getting to the end. In letter F, I have the same sort of thing going on. This one's going to be 5x minus 5 minus 12 is greater than negative 2. I'm going to start by adding 12 to both sides. Okay, so in letter, let me label this F. In letter F, I'm going to add 12 to both sides. That gets rid of the 12 on the left, and it makes the right side positive 10. Now I can evaluate the absolute value. So it's going to be 5x minus 5 is greater than 10. Greater than is the or. Greater than is the or. So it's going to be or 5x minus 5 is less than negative 10. And now I just need to solve on both sides. So on this side, I'm going to add 5 to both sides. That changes this to 15. And then I'm going to divide both sides by 5. That changes this to 3. No sign switching necessary. X is greater than 3. On the right-hand side, I'm going to add 5 to both sides. That gives me 5x is less than negative 5. Divide both sides by positive 5. That gives me x is less than negative 1. X is greater than 3, or x is less than negative 1. So let's check our work on that. And x is less than negative 1, or x is greater than 3. All right, notice that we have two empty circles, and then we shaded the region facing away from each other. All right, let's go on to letter G. Letter G is our word problem, and this one is always set up the same sort of way. And actually, we've worked problems like this in the past before that were set up very similarly. NCAA rules require that the weight of a basketball, W, used in an NCAA men's basketball game vary no more than 1 ounce from 21 ounces. Write and solve an absolute value inequality that models the acceptable weights. So here's what we're going to do. We're going to say the acceptable weight is W, okay? Or actually, I'm sorry. The weight of our basketball is W. And we're going to subtract 21 ounces from W. Now, if we perfectly have a 21-ounce ball, W minus 21 should be 0. But we don't have to have a perfect 21-ounce ball. We could be off by an ounce. So actually, all that has to be true is that W minus 21, and then we're just going to make that value positive. So we're going to do the absolute value of that has to be less than or equal to 1. So what I'm saying is when I subtract 21 from the weight of the ball, whatever that difference is can be equal to 1, because it can be 1 ounce more or 1 ounce less, right? Or it has to be less than that. But it can't be greater than 1 ounce different. Otherwise, the ball is too heavy or too light. Okay, so now I can solve this. And actually, I don't have very much to do here. I'm going to turn this into... let's see, this is a less than. So I'm going to turn this into an and statement. W minus 21 is less than or equal to 1, and W minus 21 is greater than or equal to negative 1. Okay, I'm going to go ahead and put these together. Negative 1 is less than or equal to W minus 21, which is less than or equal to 1. Okay, now I've set up this three-sided inequality. I can add 21 to all sides. So I'm going to add 21 here. That means that 20 is less than or equal to W minus 21 plus 21. I'm going to add 21 here, which is less than or equal to 1 plus 21, which is 22. That means that the least acceptable weight of the ball is 20 ounces, and the largest acceptable weight is 22 ounces. That's how we solve the word problem. Let's make sure we did that right. W minus 21 is less than or equal to 1. We came up with 20 is less than or equal to W is less than or equal to 22, and 22 ounces is the greatest acceptable weight. All right, that is how you work these sorts of problems. You're ready to do the problem set for next time.